Really did an outstanding job. So thank you, Mark. Thank you, Ross, and thank you, Mark Clark, for stepping in the way you did. Very much appreciated, and it really was exciting to me to meet people literally around the world who participate in this class and really enjoy the teaching that happens here. So I'll give a quick report on what I've been doing these past 4 weeks. Then I want to talk about an amazing set of research papers that have been published. Then we're going to jump into what we see in the book of Isaiah. And I got a whole bunch of handouts I want to hand out to you as well. But last time I saw you, I was literally within hours of getting on an airplane. And Kathy and I were heading to Spain. And you say, gee, that sounds like a really tough trip. Yeah, it was. We had to be on a sailing boat cruise. And so we really enjoyed that, but I was also a conference speaker. It was a conference cruise. And so I was speaking on that ship, and it was people literally asking questions on science and faith in the Bible, literally around the clock, nonstop. It was enjoyable. It was fun. Kathy and I were clearly the poorest people on board the ship. So, but just engaging people who are quite a bit wealthier than we are and just seeing their passion for reaching out to those who don't yet know Jesus Christ as Creator, Lord, and Savior. And there were a number of couples on board the ship that were not believers. And the fellow who sponsored this whole thing strategically had us have meals with these folks, and they're now excited about trying to learn more and getting new reasons to believe. So a very productive trip all around, and contacts I think are going to help us also in terms of strengthening our reasons to believe ministry, just meeting people who have said, hey, we can help with this, we can help with that. And so came back from Spain, and by the way, we did spend a few hours on the Rock of Gibraltar, and I actually have photos of Kathy with a bunch of these monkeys. The rock is filled with these monkeys, and they love to engage people and grab you, and they warned you they'll steal anything that you got on you. But we managed to keep our possessions. So, but we came back from Spain, was at our home for one day, and then I had to fly out to Virginia Beach. And I go to Virginia Beach twice a year to teach a week's worth of classes to the students and the faculty at Regent University. But when I arrived there, they had reserved the Monday morning for me to do a number of TV things. So I was on the 700 Club and managed to do 3 other TV things while I was there, and then spent the rest of the time teaching classes to the professors there at Regent. But they also had a day set aside where I had an opportunity to speak to the support staff. And their support staff numbered over 300. And these are people who try to recruit students and also help students get oriented and basically do the administrative tasks that are necessary to make the university run. And I think what's exciting to me is to see that these support staff were just so passionate about evangelism, bringing non-Christian people to faith in Christ, and how they could help the students and the professors there also become more effective in their evangelistic outreach. And so, and then I left immediately from Virginia Beach to St. Louis. So what's happening in St. Louis? There's a really big church there, about several thousand, and they had me do a weekend conference there. And again, a church that's very much committed to evangelism. Also, what I'm excited about, every church I've been in where they have an open mic Q&A after the sermon is a church that I notice is growing by adult converts. And this is one of those churches. And they had me speak on 3 different messages, and after every one, there was a Q&A session, and the last one, the Q&A went on for an hour and a half. And consequently, and again, people brought their non-Christian friends to participate in that. So we're hoping to take what that church has launched and sustain and really encourage other churches to do the same. Incidentally, I'm encouraging this church to do that when they have the messages here, they would follow it up with Q&A. Even if it's only like 10 minutes or 5 minutes, it sends a message to people in the community. This is a place you can come with your hard questions. And that's what church is supposed to be all about, right? A place where you can come to ask questions that you have about your faith. And incidentally, the 2 biggest reasons why people leave the church in the United States, why youth and adults leave the church, top of the list, they believe there's a conflict between the Bible and the Christian faith and science. So the fact that churches don't address the science issues is a big reason why people leave the church. The second biggest reason why they leave the church and don't return, no opportunity to ask questions. And so this is something we're trying to encourage at Reasons to Believe. So when we do have engagement with the churches, really, what can we do to promote a time when people can ask any question they want? And what we're trying to do is encourage Christians get over the fear that there's going to be an embarrassing question asked or a challenging question that can't be answered. And so their desire is, okay, we'll do that, but we're going to screen the questions. If you screen the questions, the non-Christians really see that as something that's less than genuine. And so we're encouraging churches. You need to have a Q&A where you're not screening the questions and you're taking questions from the floor. And hey, you might get a question that's embarrassing. You might get a question that's challenging. You can always say, we don't have a good answer for that question yet. Please let us research it. Or what I've done sometimes is basically challenge the person who's asking the question. You know, that's a really good question. Here's some places I think you can go to research it. How about if you do the research and you come back and answer the question for us? Or you get a group of people to work together and come up with an answer. And so it's not a problem if you don't have a good answer to the question. That's an opportunity to dig deeper and get the answer. And again, the word gets out to the community. This is a place you can come with your questions, any question, and it'll be dealt with seriously. Well, that was Grace St. Louis, and I came home from St. Louis, and again I was home for one day, and then had to go down to San Diego, and San Diego is where I've been the whole last week. In fact, just came back night before last. And what started at San Diego is we had a public event where Fuzz Rana, our staff alchemist, and myself engaged 2 of the scientists at BioLogos. BioLogos is another science faith organization, but they call themselves evolutionary creationists, and basically they have a different model of science and faith than we do at Reasons to Believe, and that they believe that the origin and history of life can be explained by natural process, where God controls the natural process, but in a way that's not discoverable by scientific investigation, or at least not yet. Whereas we take the position that there are miraculous interventions, first for the origin of life, then at many other different times throughout the history of life, and that we human beings are not the product of common descent, a position that they hold. We believe that we're the product of supernatural intervention. Yes, we have common designs with other species of life, but we're not here through common descent. So and what happened was Rana had a dialogue with Daryl Falk, who's a geneticist with BioLogos and the past president of BioLogos. And then I had a dialogue with Deborah Harzma, who is the current president of BioLogos. Both of those got recorded, and that's going to be part of the audio podcast at BioLogos. We had a video recorded, so we're going to be releasing the videos of those two dialogues. Each dialogue was about an hour long. And a dialogue in the sense it was moderated by one of the staff at the BioLogos, so it's kind of like a back and forth. So we started off that in San Diego, and then there was the Evangelical Theological Society Conference at a big hotel in downtown San Diego, along with the Evangelical Philosophical Society, and we had a booth there, so we were engaging people throughout that. They had an attendance of over 2,700 theologians and philosophers. And that was followed up by what's called ALG, which is what's called the Apologetics Leadership Group, a group that we had reasons to believe had a hand in founding 5 years ago. And it was founded basically to correct a problem in Christian apologetics. Back 5 years ago, Christian apologetics had a rather bad reputation inside the church and outside the church, and that most Christian apologists were perceived as being pugnacious and aggressive and not very gentle at all. And so we said we want to form a group of apologetic leaders and organizations that really practice the last half of 1 Peter 3:15 of being gentle and respectful and presenting the reasons for our faith, and also in doing apologetics as a tool to bring people to faith in Christ, rather than apologetics for apologetics' sake, where Christian apologists simply argue with one another, rather than actually try to develop tools to bring people to faith in Christ. So I've been involved in that for the past 5 years. And this year they had a special focus as we all gathered together on how to bring gardening back into the evangelistic ministry of churches across America. And the reason they did that, they said, so often churches have this perception that evangelism is all about harvesting, where you simply go to non-Christians, present the gospel, and encourage them to pray to receive Christ, but recognizing that that won't work if people don't yet even believe in God. Or have issues with the Bible. And so we talked about the need to bring back into evangelistic ministry the gardening, which is basically working with non-Christians, beginning to deal with some of their issues, evidences for God, and realizing this is a long process before they're going to be ready to hear a gospel presentation and pray to receive Christ. And also dealing with the problem that a lot of people think you're not even doing evangelism if you're not, quote, presenting the gospel. So we had one of our apologists there basically said, it's been more than a decade since I actually led someone through a gospel prayer to Christ, but I've spent my whole decade gardening, basically preparing people, because his whole point was the church is filled with harvesters, but there are not too many gardeners, not too many people planting the seeds, tilling the soil. And I had an opportunity to talk there as well, and saying, in gardening, we need to realize some seeds take longer than others. Like if you're planting radishes, you can have a harvest within just 9 weeks. But if you're planting almonds, it's like 8 years. And we have certain humans that are like that, right? The gardening takes place relatively quickly, but it's never in a single day or two. It's always a process of weeks. But how, for example, if you're trying to bring a research scientist to faith in Christ who's never been to church, hasn't read the Bible, doesn't know Christians, the minimum time I've seen for someone like that to come to faith in Jesus Christ has been 18 months. In fact, there was a gentleman who was attending this church here, a famous astronomer from Caltech, who was an attender here he's passed now, but it took him 35 years before, and he says, I was receptive, but I had to do all this study. And just realizing, just like with gardening, certain plants, certain trees, some come quickly, some take more time. And again, we had another speaker there basically making the point, Christians need to get in the habit of asking non-Christians questions and doing it in a compassionate way where they're actually showing that they're interested in the person, and how you can't find out what kind of plant or tree they are unless you ask questions. And so you may be talking to a radish, you might be talking to an almond. And so just trying to find out, what it's going to take for them to come. So it was a very fruitful conference that we were involved in, and it was followed by another conference. Biola University does an apologetics conference 2 or 3 times a year, and we had an opportunity to attend theirs and engage their people. That happened literally just 2 nights ago. And then it was still going on. We left because a fellow who was a long-time attender of this class many years ago, Fred Krinke, passed away. And because his children literally live around the world, they delayed his funeral. He passed on November 3rd, but his funeral was yesterday. So we were able to cut our participation at the San Diego conference short, come back and participate in that funeral. And it was a special blessing for Kathy. It's kind of like a reunion. All these people coming from around the world who used to be part of this class 30, 40 years ago, and just reuniting with them and seeing that they're all really strongly walking with the Lord. That was just so encouraging to see that going on. So, yes. I didn't need these until 7 months ago, but that happens, I think, when you get older, that you need one of these to read stuff. So, but my daughter says it's amazing I've gone as long as I have without needing these. But so my apologies there. While I was gone these past several weeks, an amazing set of papers got published that I want to just share with you briefly. In fact, there's a blog coming out tomorrow that will give the details, some of the details. This is actually going into a major chapter in the next book I'm working on. Incidentally, these past 4 weeks I've been bombarded with questions about climate change. And as you're probably aware, I'm coming out with a book on climate change in just 3 or 4 months. They now have a title. It's going to be called Weathering Climate Change, and the subtitle is a new perspective or a new approach, something like that. Weathering climate change. So literally, I've been having to deal with questions about climate change. So that book is finished, and it's being prepared now for printing, but I'm already working on my next book, and it's a book on interior designs. And it's got nothing to do with furniture. It's all about the interior design of our moon, our planet, our star, our galaxy cluster, our super galaxy cluster, our super galaxy cluster. If you were here a little more than a month ago, I actually gave a little presentation on the interior designs we see at the largest scales of the universe. So that's a book I'm working on right now, and what you'll see in a blog coming out tomorrow is just a piece of a chapter I'm writing on what's called the deep carbon cycle. And I'm also going to share with you some of the reactions of the scientists doing the research on this. These are atheistic scientists, non-theistic scientists, researching this stuff. You won't believe the kinds of comments they're making about the deep carbon cycle. But this is a little diagram of what this deep carbon cycle is all about, how we have life on planet Earth, and life is carbon-based. And when this life dies, if it's in the ocean, it takes time but falls to the bottom of the seafloor. So you've got all this decayed carbon material there. But because we live in a planet with plate tectonics, what you have is a seafloor plate sliding under a continental plate, and that causes carbon at the bottom of the seafloor to be dragged into the interior of the Earth down into the mantle of the earth. But there's another process that causes all the carbon and the carbonates that get drawn into the mantle to basically seep up and become volcanic gas. And when volcanoes erupt, they release carbon dioxide and methane back into the atmosphere. So that's why they call it a cycle. There's carbon being pulled into the interior of the earth, and there's carbon being ejected from the interior earth back to the atmosphere through these volcanoes. And this diagram here kind of gives you an idea of how complex the cycle is. I mean, it all depends on the way the plates come together, the lengths of the plates, what kind of volcanic arcs you got, where they are. And it's way more complex than this. In fact, the blog I'm coming out tomorrow makes the point that there are actually 23 subcomponents to this deep carbon cycle. This just shows a couple. There's many more. And these are the ones that are known. And then there's 37 parameters that govern the rates at which these 23 subcomponents operate. And so research scientists over the past year, for the first time, have actually been trying to do an integrated study of these 23 subcomponents and the 37 parameters that govern the rates at which they flow, and are trying to measure throughout the history of the Earth how this deep carbon cycle operates. But here's the challenge for long-term history of life on planet Earth, namely that the sun's luminosity is not a constant. It looks like this. When the sun begins to form and accumulate mass, its brightness rises to about double above where it is right now, because as a star gains mass, its luminosity goes up by the fourth power of its mass. It reaches a peak mass, and then it begins to slowly lose mass. So our sun, for example, has lost about 5 to 6% of the mass it was born with, but loses almost all of that mass in the first 600 million years after the sun is formed. And again, because the luminosity goes up with the fourth power of its mass, you see a rather rapid drop of the luminosity throughout that subsequent time when it reaches the maximum, and it drops down. And then what happens is nuclear fusion is ignited in the core of the sun. That's kind of like a gigantic hydrogen bomb where hydrogen is being fused into helium, and that's where the light and heat of the sun have been coming from for the past 4+ billion years. And it's such that as hydrogen is fused into helium, helium is denser than hydrogen. And as that hydrogen is fused into helium, that means the density of the nuclear furnace of the sun increases with respect to time, which actually increases the efficiency with which hydrogen is fused into helium. And that explains why you see the sun getting brighter and brighter from 500 million years after its birth up to its present time, and that will continue. So the sun is progressively getting brighter and brighter as its nuclear furnace burns more and more efficiently. Now, with respect to life on planet Earth, life can tolerate about a 1% change in the brightness of the sun, only 1%. And if we're talking advanced life like ourselves, it's much, much less than that. We're not very tolerant to changes in the solar luminosity at all. And so what has kept life on planet Earth for 3.8 billion years is that as the sun's been getting progressively brighter and brighter, carbon in our atmosphere has been pulled out of the atmosphere and placed into the crust and the mantle of the Earth. And so as the sun's been getting brighter and brighter, carbon's being pulled out of our atmosphere, and that carbon is in the form of carbon dioxide and methane. Both of those are greenhouse gases, and so as methane and carbon dioxide are removed from the atmosphere, that means our atmosphere becomes progressively less and less efficient at trapping heat from the sun. And the bottom line is, if you want to maintain life on planet Earth for 3.8 billion years, you have to pull carbon dioxide and methane out of the atmosphere and drop it into the crust and the mantle of the Earth at a rate that perfectly balances the increasing brightness of the sun. And what's new in the literature is they've been able to measure the rate at which carbon is pulled out of the atmosphere and placed into the crust and the interior and the mantle of the Earth. And so you can see that the rate at which it was being pulled out was quite high when the Earth was young, and now it's less and less. And again, this is what you would need in order to be able to compensate for the brightening of the sun. And this particular one shows you the total quantity of carbon in the crust of the Earth. This is just for the crust. It doesn't measure the mantle. But it shows you that as the Earth gets older and older, more and more carbon gets removed from the atmosphere and deposited into the crust of the Earth. And again, in such a way that it perfectly balances what's happening with the increasing luminosity of the sun. Now, this shows you what's being pulled into the crust. It turns out that's not quite enough to balance what's happening with the increasing luminosity of the sun, and therefore now this accounts for most of it, but not all of it. The rest of it is carbon being pulled into the mantle. And the research papers that have been published in the past few weeks are basically making the point we're beginning to get some handle on how much carbon is being pulled into the mantle. We do know it must be just enough to counterbalance the increasing luminosity of the sun. Otherwise, it wouldn't have been life here for 3.8 billion years. But we do have an accurate measure for what exists in the crust of the Earth. So back again to this particular diagram. And when they call the carbon being pulled into the crust, and some of that carbon gets released back in the atmosphere, that's referred to as the shallow carbon cycle. The deep carbon cycle is carbon that's being removed from the atmosphere into the mantle of the Earth, and then some of that carbon gets returned through volcanic eruptions. So in both cases there's a cycle, but in both cases we got slightly more carbon being removed from the atmosphere than is being returned to the atmosphere. And when I say slightly, we're talking just a few percent difference. In other words, it's not like we got a one-way movement of carbon from the atmosphere into the crust. You've got all this carbon coming in the crust, a lot of carbon leaving the crust, but there's slightly more carbon being removed from the atmosphere than what is being returned to the atmosphere by both the shallow carbon cycle and by the deep carbon cycle. But the deep carbon cycle is where we now have new understanding that we didn't have before. The shallow carbon cycle has been reasonably well understood for at least the past 10 years, but the deep carbon cycle, we've only had a good understanding of that dates back literally just weeks and months from today. But I'm going to give you a quote from one of the recent papers that has been published. And this is one actually not that recent. It's a paper that was published back in 2006 when geophysicists were first beginning to get an understanding of all the subcomponents and parameters that are involved in the deep carbon cycle. So going back to 2006, that's 13 years ago, they were aware of maybe a dozen of these 60 things that we're aware of today. But just looking at the dozen, this is what two geophysicists had to say about how we can explain how these dozen work together in such a way that we have slightly more carbon being pulled into the mantle than was being returned to the mantle, so that we can counterbalance the increasing luminosity of the sun. And at the end of their paper, they had this to write. Quote, "A very clever demon will be required to operate the carbon valve in the subduction zone." In order to, and actually what they're talking about, you actually need several valves being carefully controlled in order to make sure that you have just slightly more carbon being pulled into the mantle than what is returned from the mantle to the atmosphere. Now, this is based on just a dozen of these 60. So what I'm writing about in my blog tomorrow is saying we actually take into account all 60. Matter of fact, I think this would apply to even just the 12. We need someone a lot more clever than a demon. A very clever demon's not going to be able to pull this off. In fact, this is bad theology. The Bible tells us that God has not granted the power to any of the angels to create. He alone is a creator. That's what we've been studying in the book of Isaiah. Remember that time we spent looking at what the Bible says about the beginning of the universe and God's role in the universe? How often Isaiah, you see the repeated phrase from God, I and I alone have the power to create. Demons, no matter how clever they are, can't pull this off. It takes something a lot smarter. But I'm impressed that these scientists who are not coming from a theistic perspective are recognizing you need somebody with a lot of intellect, knowledge, control, and power to make this work. You're not going to be explaining this by natural process. And this is just one of several quotes I'm finding in the scientific literature where these non-theistic scientists are looking at this and saying, kind of throwing up their hands and saying, I don't know how this can work unless there's something with extreme intellect and power that's controlling things behind the scenes. But I also find it interesting that rather than credit the God of the Bible, they're actually willing to credit a clever demon. So, now, I like to spend the remainder of our time looking at our study in Isaiah. And if you didn't get, well, first of all, let me distribute the study questions in case you didn't get them. You probably all have them because I've actually distributed over 500 of these in this class. And I know we don't have 500 members here. And this is posted online for the live streamers. But if you didn't get a copy of the study questions, didn't bring one with you, these are the dozen questions we're looking at. You can take that. And one of the things people have said they really appreciated was the study we did on the passages in Isaiah that speak about the cosmic beginning. And we put it in relatively small type, but we all got it down to one page. These are all the passages in the book of Isaiah that speak about the beginning of the universe and God's role in it. If you didn't get a copy of this, again, take one. And again, this is something that's posted at paradoxes.org. So I don't know if we can get someone to distribute these. Any volunteer? Thank you. And complementing that are passages that we have on the end of the universe. And again, we've reduced this to one page because there aren't quite as many passages. We got it in slightly bigger type. So if you didn't get this, you can take a copy. And again, this is posted at paradoxes.org if you didn't get that. And then finally, we've been looking at the questions that pertain to what Isaiah says about the time of the end. And in particular, we've been looking at what it says about the second rebirth of Israel as a nation. And I think I've handed these out before, but I'll hand them out again. And again, I've only handed out a couple of hundred of these, so I brought more of these. We got 60 of these. So thank you. Thank you. Yes.
Before you move on, all that black is the carbon in the illustration?
Okay, that black is basalt. I mean, basalt as compared to silicates. Silicates are what continents are predominantly made of. The tectonic plates in the ocean, we call these oceanic plates, they're predominantly made of basalts. And if you've ever been walking on basalts, they tend to be a dark kind of rock. But you are onto something. These basalts, by the way, oceanic plates are much thinner than the continental plates, and they're a little denser, and so therefore that explains why they tend to slide under the continental plates. The continental plates being made of silicates are lighter, and so they tend to float up. The oceanic plates, being denser, tend to sink. And then because our planet is so super endowed with uranium and thorium, there's heat flow coming up from the interior of the Earth that actually causes a chemistry to happen here where you get talc being manufactured at the place where the oceanic plate is making contact with the continental plate. As you know, talc is a lubricant. So it actually helps these plates to slide under one another. And there is carbon falling on top of those basaltic plates. Why? Because the oceans are filled with life. And most of the carbon comes from microscopic life. A lot of microscopic life will pull calcium and carbon out of the ocean and make shells. So we often think of shellfish being like oysters and clams and crabs, but what's predominant amongst shell life are microscopic life forms that build a very thin calcium carbonate shell around a single cell. And when those creatures die, they tend to sink towards the bottom, and therefore their calcium carbonate remains, accumulate on the bottom, and that calcium carbonate and other carbonates will slide underneath the continental plates and get driven into the mantle. And so what's happening is that mantle material is being hydrated because water gets pulled in as well, and then the carbon gets pulled in, so the mantle material gets chemically transformed. Some of that carbon will remain there permanently. There are other processes of heat and pressure that cause the carbonates to be broken down and then released as carbon dioxide and methane through plumes, through volcanoes, and what they call seeps, where you get these little fissures where the stuff will come up. But that gives you an idea of just some of these extra subcomponents. You need a fracturing of the basaltic plates to happen. That's what allows water to go down. You need the water to go down on the mantle in order to produce those lubricants that allows the plates to come together. One of the quotes I didn't show you is from a review of this whole process where they're making the point that for all this to work in such a way that you get more carbon being pulled into the interior of the Earth than carbon that's released back to the atmosphere, you need these plates. You need the plate tectonics to be very efficient and very long-lasting, and basically making the point, namely that this requires such extraordinary fine-tuning design. Earth is likely the only planet in the entire universe where this even operates. Yes?
How does the calcium return?
Oh, we're going to, by the way, microphone. I'll get back to you, because sorry, I haven't been here in a while, and I keep forgetting about the live streamers who need to be able to hear all of you. So wait for the microphone. We'll get to you in a minute. Go ahead.
Dr. Ross, you might have covered this, but I missed it somehow. What is the continental crust? What material is that made of? It's probably varied, right?
Continental crust is predominantly made up of different silicates. And, when rain falls on the continental land masses, some of those silicates get converted into sand and carbonates. But when you look at a continental landmass, it's predominantly silicate. When you look at an ocean floor plate, it's predominantly basalt. And, water can react with the basalts and make silicate. And so the fact that we have these oceans on planet Earth explains how, because our planet began with a crust that was all basalt. But the reaction of water with a basalt makes a lighter material, namely the silicates, and then some of that silicate gets converted into sand and carbonates. So, but again, here, go ahead.
Okay, so it's working?
Yeah.
Okay, so how does you said the calcium gets subducted into the Earth. How does the calcium return? What is the calcium cycle?
What's the calcium cycle? Okay. And again, when we're talking about carbonates, calcium carbonate is the one I think we're most familiar with, but it's not the only carbonate. I mean, you can take, CO3, which is a carbonate, and you can chemically react it with any metal. So you can get zinc carbonate, calcium carbonate, all the other metals, sodium, it can react with. But calcium carbonate is what we most commonly see with animals. Zooplankton and shellfish will take calcium out of the seawater and react it with a carbonate, and they make a shell. And then when that creature dies, those shells can sink to the bottom, and that gets subducted into the interior of the earth. And typically the calcium can return back. Not all of it does. Likewise, not all of the carbon returns. And so that calcium can seep back up. Again, that's something that's not yet fully measured. What these geophysicists have been able to do, and geochemists, they're really most interested in what's happening to the carbon, because that's basically what's going to determine whether or not life can remain a long time in the earth. In terms of trying to trace the cycling of the metals, they do know the metals are being cycled. After all, we're able to mine this stuff, so somehow it gets back into the crust of the earth. But exactly how and what rates, no, that's not yet been determined. Just like they're still trying to measure with some precision the deep carbon cycle. We got a really good measurements on the shallow carbon cycle, deep carbon cycle. Again, we know it works in such a way to counterbalance the sun. So bottom line is we really don't know that much about it yet. Okay, any more questions before we jump back to the Isaiah text? Yes.
So my question just is that, since the beginning of the industrial age, mankind has been releasing carbon into the atmosphere. Are we releasing enough to actually throw off that balance, or is it negligible as far as this balance between carbon taken out of the atmosphere and carbon being released again?
Well, the answer to the question will be in very considerable depth in the book Weathering Climate Change. So if you're willing to wait 3 or 4 months, you can get a detailed answer, but I'll give you a quick answer right now. Namely that we're living in an ice age cycle where the orbital features of the Earth and our rotation axis feature varies in such a way as to cause this ice age cycle where we have like about 90,000 years of 20 to 23% ice coverage of the planet, and about 10,000 years where you get 10% coverage. So this is being driven by these natural cycles. And right now we're in a time of the history of the Earth where the decreasing tilt of our rotation axis and the decreasing eccentricity of the shape of our orbit around the sun is causing cooling. So we're in a cooling phase right now. And we've been in a cooling phase for the past 9,000 years, 8,700 years to be precise. And normally these orbital and rotation axis tilt would cause dramatic cooling. Typically they cool the planet by about 15 degrees centigrade over a time scale of 1,000 or 2,000 years. In this particular ice age cycle, that did not happen. Because of an asteroid that hit at just the right time and just the right place, instead of the global mean temperature doing its normal rise to a peak about 2 to 3 degrees centigrade above where we are right now, this asteroid collision took place right in the middle of that warming period and actually cooled the planet in such a way as to prevent the global mean temperature from going up to its normal maximal range. It literally stopped 3 degrees centigrade short of the maximum, and it also engendered a brief period of climate stability. And with that climate stability, humans launched civilization. It's referred to in your history books as the Neolithic Revolution, which began about 11 to 11,500 years ago. and began because humans saw this climate stability, took advantage of it, and were able to begin to specialize with their agriculture, scale up. For the first time, they could grow way more food than what they needed, which meant that they didn't have to have the whole population focused on food. And so for the first time, significant fractions of the human population could be released to do music and art, science, engineering, and technology, which explains why the human population began to rapidly rise and why technology and civilization began to rise. The rise of the human population and civilization and technology resulted in more carbon being pushed into the atmosphere. Because humans began to figure out how they could use coal and how they could use wood, and how through the domestication of cows they could come up with more meat and more cheese and more milk. The domestication of rice, they could produce an abundance of food. But the domestication of rice and the domestication of cows resulted in a huge increase in methane and carbon dioxide going to the atmosphere. Bottom line is this: the natural cycles were cooling the planet. The launch of human civilization and the acceleration of human civilization warmed the planet, and the two have counterbalanced one another. And so what you'll see in the book Weathering Climate Change is how the two counterbalance one another so perfectly that over the past 9,500 years, the global mean temperature did not vary by more than plus or minus 0.65 degrees. Incidentally, that's a new data point. If you read books on climate change, they'll say we've been in a period of climate stability where the global mean temperature has not varied by more than plus or minus 2 degrees centigrade over the past 9,500 years. We now know that's way too conservative. It hasn't changed by more than plus or minus 0.65 degrees. In other words, it's more than 3 times as stable as what we thought. And it's that extreme stability that's enabled us to build up a population of more than 7 billion humans, and to be able to have the technology and the civilization where we can have a high standard of living, but also have the technology to be able to take the good news of salvation through Jesus Christ to all the people groups of the world in decades rather than in millions of years. And so I'm actually arguing Weathering Climate Change. This is all the hand of God on the natural cycles, the hand of God on the development of human civilization in such a way that we can have this long period of a climate stability. Now here are the details. If you look, we hit a peak temperature 8,700 years ago. And it took 8,700 years with the expansion of human population and technology counterbalancing the natural cooling cycles, so that over those years, 8,700 years, the global mean temperature very gradually and steadily declined by 1 degree centigrade. And so we're actually a degree colder now than we were 8,700 years ago. That was in the year 1900. 1950, we were still there. What's happened from 1950 forward, we've gone up by a whole degree. So it took 8,700 years to decline by 1 degree, and the last 70 years has gone up by 1 degree. And that explains why there's some concern over global warming, because if that were to continue, we'd wind up going back up to 3 degrees centigrade above where we are now. And our knowledge of the Ice Age cycle tells us whenever you hit that peak temperature, you melt the polar ice cap. When you melt the polar ice cap, you get way more snow falling on Canada and Siberia, and that drops the planet very quickly into an ice age. Moreover, the natural cycles are still working together to cool the planet. And so if we melt the polar ice cap with these natural cycles, we're going to very rapidly drop into a big ice age. So that's kind of the background. But what I really put in the book is there are ways that we can prevent the melting of the polar ice cap and extend this climate stability while we boost the world economy. So it's kind of the anti-Al Gore book. You know, Al Gore brought out his book, An Inconvenient Truth. In fact, I was trying to talk our staff into titling our book Convenient Truths, but that didn't fly. They said, no, we want something a little more conservative. So it's weathering climate change. But it's the opposite in a sense. Instead of calling the world's peoples to dramatically cut their standard of living so we can stabilize the climate, we're basically saying there are win-win solutions where we can stabilize the climate while we put more money in everybody's pockets. And who's going to vote against that? So one of my motivations for coming out with the book is to take the politics out of the global warming controversy. Yes, the climate is warming, but there are ways we can stabilize the planet in such a way where everybody wins. Incidentally, that's based on a biblical principle. When you read Genesis 1 and Job 37, 38 and 39, those are the creation care texts of the Bible. And what they communicate is that God put us humans here on planet Earth and gave us the command that we're to manage the resources of planet Earth for our benefit and the benefit of all other life. Basically making the point we will not have to choose between our benefit and the benefit of the rest of the life on planet Earth. Namely, that God has provided us with solutions that will benefit us economically and benefit all other life as well at the same time. So I've got 2 chapters in the book basically filled with ways that we can stabilize the climate at the same time boost the world economy so that everybody wins. Who's going to complain about that? So we'll see what happens with the Al Gores when they read that book. So I think they're going to like it. Go ahead.
I'm just trying to understand the scale of what we're looking at, and I'm assuming that the volcanic arc covers like maybe 20,000 feet. What's the scale in a matter of miles?
Okay, this is a diagram where nothing is to scale, okay? It's basically designed to show you what plate subduction is all about. So, please don't look at that as showing you how tall the mountains are and how far down and how thick the ocean plates are. Typically, the ocean plates are a factor of 3 to 8 times thinner than the continental plates, to give you some sense there. But one of the things that has to be fine-tuned to make all this work so life can be sustained on planet Earth, the subduction zones, where you've got an oceanic plate sliding under another oceanic plate or underneath a continental plate, the lengths of those zones must be fine-tuned. In fact, you need to have thousands of miles of subduction zones over the face of the Earth in order to pull enough carbon into the interior Earth to make this cycle work in such a way you can have life long-term on planet Earth. Likewise, these volcanic arcs have to be fine-tuned. So you need to have, and again, there is no other planet where you've got mountain ranges as long as we have here on planet Earth, or with the volcanic activity we have here on planet Earth, or with the subduction zone activity we have here on planet Earth. I mean, that's a couple of the quotes I'm putting into this next book I'm working on, is basically making the point there's a growing recognition that this is so phenomenally fine-tuned and so unusual, we're not going to find it anywhere else. As I said here in the class before, this planet we're living on is the uranium thorium champion of the universe. And it's only because we're so super endowed with uranium and thorium that this is able to operate for 3.8 billion years. In fact, it operates for about 4 billion years. To put this in context, if we look at rocky planets about the same size as ours, orbiting their host stars about the same distance ours does, and look at their uranium and thorium abundance compared to what we have here on planet Earth, we have 630 times as much thorium. and 340 times as much uranium. Nothing comes even close. And wasn't for that huge quantity of uranium and thorium, there just wouldn't be enough heat flowing out of the interior of the Earth to make these processes work at a level that's necessary to ensure that we can compensate for the increasing luminosity of the sun. As some of these authors have pointed out, we might be able to conceive of life on another planet, but it's life that's not going to last more than 1 million years. To have life remaining for 3.8 billion years, you need all this to be operating. It's not going to happen without all that huge quantity of uranium and thorium. Any more questions? Yes.
I had a quick one. When you said when the poles melt, that we rapidly go into an ice age, how many years is that?
Okay. I mean, just to give you some idea, over the last 50 years, about half of the summer polar ice cap has disappeared. So the summer polar ice cap's only half the size today that it was 50 years ago. And that's why there's some concern. Okay, we keep warming the planet. Could that polar cap disappear? And again, what's new in the literature is the recognition. Okay, if you've got ice covering the Arctic Sea, that ice reflects sunlight with 60% efficiency. If you don't have ice, if you've got open liquid water, that open liquid water reflects sunlight with only 6% efficiency. So that's an enormous difference. And what that means, instead of this heat being reflected away from the sun, it's absorbed by the Arctic Ocean. And when it's absorbed by the Arctic Ocean, that means you're going to get more water vapor coming up above the Arctic Ocean. That water vapor, because it's still cold, is going to fall as snow over the adjoining land masses. And so instead of Canada and Siberia, I mean, if you look at the northern part of Canada, the northern part of Siberia, right now they actually qualify as deserts. They only get 10 inches of precipitation per year. The reason why you got forests there and tundra there is because it's cold enough where that 10 inches actually enables the plants to grow to the degree they do. But because it's only 10 inches, the snow does not accumulate. But if you have a lot more snow falling there, and say it becomes 20 inches or 30 inches, now the snow will accumulate year after year after year, and in a relatively short period, you get thousands of feet of ice covering Canada and Siberia. To answer your question, how quickly can that happen? It can happen within 1,000 years, where you go from having Canada and Siberia being ice-free and snow-free in the summer to where now the snow is accumulating. Now, I'm talking 1,000 years, 1,500 years maximum before you get thousands of feet of ice, but you're going to get hundreds of feet happening in a lot less time than that. And all you need is, say, 10 feet of ice to be permanently there, which means nothing's going to grow. So the forests will disappear, the flowers will disappear, the tundra vegetation will disappear, even with just 10 feet of ice covering those regions. Okay.
Well, if I'm reading this right, I thought I understood that the peaks between ice ages indicated that that was a peak that melted snow. But I think what I've heard is that partway to that peak is when the snow and ice is melted from the poles, but maybe the temperature continued to rise while the poles were still frozen, but the ice was building up on the land masses. Am I reading that right? Because I thought when we interrupted the last climb to that peak, that it's prevented another ice age from coming in. So
Well,
I'm wondering, how do we get a cooling influence without the ice buildup first?
okay, you're basically moving the ice from the Arctic Ocean onto the continental land masses of Asia and North America and Europe. And so, and that ice covers a lot more area than the Arctic ice cap ever covered. And so you get a much more significant cooling effect. Moreover, that ice is now at a lower latitude. And the lower the latitude, the more efficiently it reflects sunlight. So for example, the ice over the Tibetan Plateau reflects sunlight 4 times more efficiently than the ice over Antarctica. And it's just because of the angle at which the sun hits that. So like at the Arctic, the sun's angle is kind of like this, whereas towards the equator, it's more of an acute angle. And so you get a greater efficiency of the reflection of heat away from the sun if it's at a lower latitude. So I don't know if I answered your question properly. And maybe the enigma is this, is that people said, well, if we warm the planet where we melt the polar ice cap, how do you get snow falling on Canada and Siberia? Well, take a visit in the wintertime to northern Canada or Siberia. Temperatures will be like -70, -80. It's really cold. If you warm the global mean temperature by another degree, that could make the Canadian Arctic as much as 5 degrees warmer. So instead of being 70 below, it's 65 below. You put extra water vapor above Canada, it's not going to fall as rain. It's going to fall as snow. Even if you were to warm it up by 20 degrees, it's still going to fall as snow, just because of how cold it's there now in the winter time. And so putting more water vapor in the atmosphere is a problem. And when you melt the polar ice cap, you're putting more water vapor above those continental land masses. So yeah, indeed, the world becomes warmer, but it doesn't become warmer enough to transfer that snow into rain. It's going to fall as snow. And incidentally, what we've seen in previous ice ages, the sign that you're about to experience an imminent ice age is where you begin to see snow and ice accumulating first in western Siberia, and then secondarily where you begin to see it accumulating in Labrador. If you see it accumulating in both places, you know an ice age is coming. 2 papers have been published where geophysicists are thinking we may be seeing the beginning of the accumulation of snow and ice in Siberia. So it's causing some alarm already. They say that's because we've melted half the polar ice cap. But we're seeing no buildup of snow and ice in Labrador. So it's not imminent. But the very fact that some people think we're seeing it in western Siberia is a cause for concern. Okay, one more. Yeah.
Well, every time this subject of climate change comes up, I keep thinking about what the last 1,000 years were like, in which there was at least a medieval warming period. The Vikings came to North America and
Right.
some feisty natives and decided they couldn't settle there. And then north they found this green land. It was very green. They settled for over 100 years, raised crops, had a great time, thought it was a wonderful place. Then after about 200 years it turned cold, and finally the ones that had returned to Scandinavia, the last colony perished in the winter. Also during that time there was a 300-year drought in the American Southwest, caused the dispersion of the Anasazi civilization. They had irrigation systems and roads, and they were very well settled, and they had to disperse into the Hopi and other tribes. And also England during that time, particularly for growing grapes, it became so warm and sunny. And then there was a 15th century Chinese expedition that reached very high latitudes towards the Bering Strait. They were able to measure latitude well, not longitude, but they encountered no icebergs. And then I read Newsweek, it was one of the news magazines that had an article in around 1932 that said that the Northwest Passage may soon be open because of all the melting of the ice.
Right.
And then in 1970, a Newsweek article said there might be an ice age coming. The climate is changing. And so I keep thinking that putting all these things in perspective, all the changes that have occurred in the past before the Industrial Revolution, I think need to be accounted for, and also to recognize what we can change in the climate and what we cannot change. We understand the forces, including the millennial ocean current cycles that have a tremendous effect on climate.
Yeah. Okay, what you're going to see in weathering climate change is the latest assessment of that medieval warming period, followed by the Little Ice Age. Those are the two anomalies we see over the... By the way, there's others. There was one at the time of the Romans where there was a warming period, another one that goes back 4,000 years. So what's kind of new is a group of geologists and geochemists have basically looked at 74 different proxies for the global mean temperature. What caused some confusion a couple of years ago is that we were trying to determine the global mean temperature over the past 10,000 years by using only one or two proxies. And so now they're using it 74 different proxies. And what they're showing is these proxies have different reliability measures for different regions and different times. And so no proxy gives you a reliable temperature record over the whole period, but with 74, they're able to get, for the first time, an accurate sense of what was really going on over the last 9,500 years. And it's those proxies, too, that have basically showed that the last 9,500 years have been far more stable than we ever thought. And a part of that reanalysis is basically showing us that the medieval warming period wasn't as warm as what we previously thought. It's basically shrunk by about a factor or two. It's about a 0.5 degree centigrade warming effect. And then likewise, the Little Ice Age is not quite as cold as what we originally thought. It's been shrunk also by a factor or two. And how that compares with what's been going on in the last 70 years is that the medieval warming period was much more gradual in terms of the increase in temperature and then the drop back down. Likewise, the Little Ice Age is much more gradual. What we've seen over the last 70 years is you get a 1 degree centigrade jump in just a 70-year period, which is something that's never been seen before over the past 9,500 years. And likewise, when you look at the two warming periods at the time of the Roman Empire, a couple of thousand years ago, and another one about 4,000 years ago, they're roughly the same as what you see in the medieval warming period, but evidently lasted even longer than we see in the... and again, you're right, they're now thinking what's driving these small excursions from climate stability is the Atlantic Mediterranean cycle. There's a cycle of ocean currents in the North Atlantic that is now finally beginning to be understood what's driving that, how it pulls carbon out of the atmosphere and returns carbon to the atmosphere. And so again, that's what's kind of new, is we're now getting a good understanding of what's happening with what they call the AMOC. Sorry, I thought somebody was there. It's just a microphone. And I think that's why I'm coming out with this book, is basically saying for the first time, we got data that's a lot more trustworthy, and where the measurements are now a lot more pinned down. And it's actually giving us a picture of what's going on that we've never had before. But again, to your last point, what I've really tried to put in the book, here are things we can do that basically fulfill the biblical mandate. Manage the planet's resources for your benefit and the benefit of all life. And basically showing multiple ways that we can stabilize the climate and not just boost the world economy by a little bit, but by a large amount. And I think one thing that might motivate the nations of the world to pursue all these, you're probably aware financially, the nations of the world are accumulating a lot of debt. Our nation is, but we're not the only nation. Nations all over the world are accumulating debt, which I think is bad news for our grandkids. But by coming up with these significant boosts to the economy, we can actually do something about national debt, international debt, never mind individual debt. Because Americans today are carrying more debt than they've ever had in the history of the U.S. In fact, that's what's interesting. You can go back 70 years, and America had huge surpluses, and that's no longer the case. So I think there's going to be a stronger motivation to really pursue some of these initiatives. The one thing that I notice with these people that are pushing for economic sacrifices, they're ignoring another biblical principle, which is that human beings are fundamentally selfish. And if they're fundamentally selfish, motivating them to cut their standard of living by a factor of 3 or 4 isn't going to get you anywhere. If you don't believe that, try that with your children. In fact, that's something I did with my son, saying, hey, how about if we restructure our family finances so that you got 3 times less than what you got right now? They were not very enthusiastic about that. And if that doesn't work with teenagers, it's not going to work with nations either. Okay, one more? Okay.
I read in National Geographic magazine that the solution to feeding all the people on the planet is bugs, and it had a chart of the, different food values of the different bugs and stuff. And it doesn't sound very attractive. But,
Well, that reminds me of a Christmas gift I got from my brother-in-law last year, which was an insect cooking book that I've never really put into practice.
So that was just a comment. But, my question is, about the salinity of the ocean, does that affect climate a lot? Or?
It does. Matter of fact, this carbon cycle I've been talking about, one of the big factors is the salinity of the oceans. So the salinity of the ocean must be fine-tuned to make this work at a rate that's going to be required to compensate for the increasing luminosity of the sun. The pH of the oceans likewise must be fine-tuned. Our oceans right now are very slightly alkaline. If you increase the alkalinity a little more or the acidity a little more, you throw it out of balance. It must be fine-tuned. Okay, we have one from the internet. Yes.
It's kind of an unrelated question. But RJ wants to know, he said they read that sugar was found in a meteorite.
Yes.
He thinks it was ribose?
Right, it was ribose.
Does the ribose discovery have an effect on the origin of life on Mars, since ribose hasn't been naturally found before?
Yes, I think I'm going to have to write a blog on this because I'm getting so many questions about the discovery of ribose in a meteorite. And the reason why that's generating excitement, you cannot put together nucleobases to make RNA and DNA without ribose. Ribose is a 5-carbon sugar, and this is the first time they've ever found a 5-carbon sugar or a 6-carbon sugar outside of a living system or the decay products of the living system. They have found 3-carbon glycoaldehydes, which are kind of sugar-like. They've never found anything past 3 carbons, 3 carbon atoms. This one is 5 carbons. And so it's generating a lot of excitement, saying maybe this is the answer to the origin of life. We finally found a natural source of ribose. I'm not personally surprised that they found this ribose. Number one, we have found over 135 carbonaceous molecules in dense molecular clouds throughout our galaxy. And based on what we discovered, we know that there must be a chemical reaction working there that makes ribose. However, we astronomers have been searching for ribose in these dense molecular clouds, and to this date, we've not found any. And that's because I believe they're at such a low abundance level, it's going to be difficult to discover. And that's because the reactions that make ribose, there's also reactions that destroy the ribose. But I believe if we continue looking with our radio telescopes, we're going to find ribose. Just because we know the chemistry is actually operating there, it's got to be there. But it's probably going to be a parts per billion. We've already ruled out parts per million. It's much less than parts per million. And the problem is if we're talking parts per billion, that's way too low of an abundance level to help any conceivable naturalistic origin of life model. The fact that they found ribose in a meteorite is not surprising to me because with meteorites, we can measure abundance levels much lower than what we can in dense molecular clouds. And that's what happened. They found a very low abundance level of ribose, and again, too low of a level to be of any help for any conceivable naturalistic origin of life model. Another problem with the ribose is it cannot be used to assemble nucleobases to make RNA and DNA unless 100% of the ribose is right-handed. Ribose is a chiral molecule, and it's going to be 50% right-handed, 50% left-handed. And you'll see a chapter in our book, Origins of Life, that I've written on what's called the homochirality problem. Namely, you cannot make amino acids to assemble to make proteins unless all the amino acids are left-handed. And you can't assemble the nucleobases unless all the ribose is right-handed. And experiments have been done about how we can select these amino acids and get them all left-handed. And there are a couple of mechanisms in physics that will destroy the right-handed amino acids a little more efficiently than the right-handed amino acids. And the best option has been circularly polarized ultraviolet light coming out at just one wavelength. And what I've written about is, number one, that doesn't help the origin of life map models because there is no source of ultraviolet circularly polarized light where it all comes out at just one wavelength. That can work in the lab. We see no evidence of that. There are places in the universe where we do see circularly polarized ultraviolet light, but it's at all different wavelengths. And the problem there is you run into what's called the Condon-Kuhn rule, which basically says this wavelength will destroy right-handed amino acids more efficiently than left-handed amino acids, but the adjacent wavelength does the opposite. It destroys left-handed more efficiently than right-handed. So it only works if you get all the ultraviolet radiation coming out at one wavelength. And there is no naturalistic source where that happens. But they've done experiments in the lab. And the last Origin of Life research conference that Fuzz Rana and I attended, it was focused on this problem, where they create this laboratory scenario. They blast these amino acids with circularly polarized ultraviolet light at only one wavelength, and they do destroy more right-handed ones than left-handed ones, but they discovered they hit a limit at 80% left-handed and 20% right-handed. As they push beyond that, what they're discovering is you wind up with no amino acids at all. I mean, yes, you are destroying the right-handed ones more efficiently than left-handed ones, but you are destroying all the amino acids at a certain level, and as you push towards 100%, the sample that remains is zero. That was one of the latest research findings. They said, as we project beyond 80%, once we get past 95%, we got no sample left. And we would argue that you're going to run into the same problem with ribose, although the experiments have not yet been done with ribose. That'd be a good thing to do. Okay, we found a natural source of ribose. Let's see if what happens when we try to get everything right-handed. But already I can tell you the quantities we're finding are not going to help naturalistic origin of life models. Moreover, there are other missing building blocks. In terms of amino acids, there are 20 biologically essential amino acids to make proteins for life. They have found 6 of them in these meteorites, and they've yet to find any in the dense molecular clouds. Again, that's a problem. If you're not finding any amino acids in these dense molecular clouds, that means you're dealing with a very low abundance level. But just like with the ribose, they have found 6 of them in meteorites. But they found the 6 simplest amino acids. The 14 complicated amino acids have not yet been found. The most complex is tryptophan. By the way, when you eat turkey, you're consuming tryptophan. That's one of those 20 amino acids. Those are the ones that make you want to take a nap. So if you want to sleep well, consume lots of turkey meat, and you'll get a good dose of tryptophan. But it's the most complicated amino acids, and it's sufficiently complex I don't think there's any hope of ever finding a naturalistic source of tryptophan outside of a living system or the decay product of a living system. So ribose is not the only, quote, missing building block. Matter of fact, I can share this with you briefly before we get into the, we're kind of out of time as it is already. Okay. At the last Origin of Life Research Conference held at UC San Diego July before last, they had 5 speakers get up to address the problem of the missing building blocks. And the question was, will we ever understand the origin and the source of the building blocks of life? And 5 speakers got up to speak, and they all said no. Matter of fact, they all agreed with this. Not only do we not understand where the building blocks of life molecules come from, we have no idea where the building blocks of the building blocks come from. And yet they're thinking we can explain the origin of life by naturalistic means. Incidentally, that was part of the debate that we had with BioLogos just a couple of nights ago, was this whole issue of the origin of life. Basically making the point we already know enough about the origin of life to realize it can't possibly be a naturalistic pathway. It's not just a mystery, it's something we now know has no possibility of a naturalistic answer. With that, I'm out of time. Bring back that stuff on Isaiah, because we're going to get to that next time. And thank you, all of you who are participating online. And again, feel free to show people paradoxes.org. Every one of these classes is video recorded, and the video recordings are where we get our biggest audience. So I don't know how many of you are here, but we get about 4,000 or 5,000 that watch what's going. So behave yourselves next time you come here, because you are on camera. With that, let me pray. Father in heaven, thank you for this time we've had. Lord, this amazing discovery, the deep carbon cycle, is a mind blower. Thank you for the questions that have been asked here in the class. And Father, I pray that we be able to use what we're learning here from the book of nature and from the book of Scripture to bring people to an awareness that there is a God out there, a good God, a God that desires good things for each one of us, a God that desires to redeem us from our sin and evil. So make us fruitful, Lord, as we share this good news. May we see many come to know you as Lord and Savior as a result. In Jesus' name, amen. Thank you.